Hello, ladies and gentlemen, and welcome back to another Earth Science screencast by yours teacher, Mr. Stano. And today we're going to go into looking at what these three pictures have in common. We have sand down at the bottom, the Grand Canyon, and then we have a statue. If we take a look at the three, we can see that sand, we all know we live on Long Island. We've been to the beach before. Very small particles. Grand Canyon, some people have been there. Others have not, but we can see here that it looks like it's mostly rock. We got some river flowing through the bottom. And then we have this statue right here, which definitely does not look like it was made that way. There's definitely been some sign of it being broken down right here. Well, is it a possibility that as the Grand Canyon breaks down, it turns into sand? Or maybe even the face of this statue, as it broken down, turned into sand? It is a good possibility. These three pictures have in common is that they've all been weathered or are as a result of weathering. So what is weathering? Weathering is a physical or chemical process that changes rock or breaks down rock. That's it. That's weathering. For weathering to occur, the rock or the substrate or the material must be exposed to the air, water, or human and or animal activities. Physical weathering. Physical weathering, much like we see here, we had at one time one giant rock, and something happened where it split into two. But the left side and the right side, for the most part, look similar or are a part of the same rock. Similar to when we get to the split rock right here, we could see that these two sides definitely made up one whole rock at some time, but really they look the same. As the same with this picture too. All these rocks have been physically weathered or mechanically weathered. Mechanically weathering or physical weathering of rocks, basically we break rock up into multiple pieces without changing the chemical composition or nature of the rock. The first type of physical weathering we will come in contact with is frost action, and it's very prevalent here on Long Island. Frost action, also known as ice wedging, has to do with the alternate freezing and thawing of water. So we know that if we put a container filled with water in the freezer, that it'll actually crack that container because water, as it freezes, it expands. And what we see with frost action is that water will seep down into cracks of rock. As it freezes, it pushes the rock out as it expands, much like that container that we saw in the freezer. As the year goes on, the ice will melt, more water will get back into these cracks, and when it freezes, it'll cause it to even work farther and farther. So the years or the alternate freezing and thawing of water will cause cracks to develop in structures or in rock and ultimately breaking off pieces. Potholes are a result or partly are a result of this freezing and thawing. What we get here is that water is going to make it into any cracks in the road surface. It's going to freeze and it's going to cause the pavement to pop up a little bit. Then when a plow comes, the plow itself will catch hold of that piece of road that's sticking up a little bit and pull it out of the ground. So potholes are a result of this alternating freezing and thawing. The next type of weathering we have is abrasion, and it's very similar to sanding. Basically, running water, wind, can cause sediments to rub up against each other, and when we do that, they wear down the surface. Much like what we see here, that as the sander goes around, it's got little pieces of sand on the sandpaper, and they're rubbing against this surface, ultimately wearing it down. Wave action, very similar. Basically, it's going to do the same exact thing we saw with abrasion, is that as the water comes in, it's going to carry very small particles with it, and as it carries the particles, they're going to hit a surface and be dragged back, so they're rubbing against each other. And it's the same here. The wave's going to come up, crash into here, and come back. That movement of sediment is going to act as sandpaper. Much like we see with wind action. Wind action will carry the sediment, and when it carries the sediment, it's going to cause it to bump into other little pieces and break down rock. Sandstorms right here, like we see in Kansas City, or this one right here, are very detrimental to the landscape and the features on it. And not to mention automobiles, as we get that sediment inside the air, if they make it past the air cleaner, can break down the inside of a motor. So it's not just rocks that can get weathered. We also have plant or root action. What happens here is that the plant will actually grow into a surface, and the roots will make their way down into cracks. As the plant grows, there's water within those roots, and it helps push apart or create forces that push apart the material or the rock, breaking them down. And we can see here that as it breaks open, it exposes new surfaces where the roots can grow and push apart. We can see this on sidewalks. We've probably seen this before. As the root or the tree grows, it pushes it up and out of the way. Or sometimes you'll see trees growing on the side of barren rock. It's because their roots are down in cracks where there is more substrate for them to take advantage of. What we can do is put barriers up, basically metal barriers, to stop the roots from growing and causing that pushing up of sidewalks. We don't see it too often, but we can do it. Finally, we can have human interaction or the breakdown of rock, which we do all the time. Mining is a great example of that, where we'll put in explosives, break open whole rock faces, and to get in and excavate out the materials we want. Digging of animals or humans basically break down rock into finer particles. Okay, that's it, ladies and gentlemen. We'll go on to this next time. I hope you enjoyed this screencast into physical weathering. Have a great day.